In this video, we're going to be looking at types of experiments. So AQA requires you to know, as part of your research methods knowledge, the experimental method, which includes our 4 types of experiments. These are a laboratory or a lab experiment, a field experiment, and then we have our sort of not true experiments, but we have 2 other types of experiments, the quasi or the quasi. So, when we're talking about types of experiments, we all know what an experiment is. An experiment is where there is an IV that is manipulated. We typically have conditions of the IV, where we've got the IV in one condition and then no IV in the other. And then we measure the effect of the manipulation of the IV on the DV. So that is sort of the basic principles of any experiment, is the manipulation of an IV to test the effect on the DV. But the type of experiment that we do is going to differ. So when we're talking about types of experiments, what we're really referring to here is how the independent variable was varied and under what circumstances. By how, we're really talking about, was the IV manipulated by the researcher, or has the IV emerged, these conditions, have they emerged based on factors beyond the researcher's control? We also might want to consider the circumstances under which that independent variable is being manipulated. In other words, where is the experiment taking place and how much control is there over situational variables? So let's jump in. I'll go through each one in turn, and then we'll have a look at some comparisons and a useful tree diagram, which can help us to make some decisions about the type of experiment that we might be seeing in a scenario. So let's start with lab experiments. A lab experiment is probably the most common type of experiment that you've encountered so far in the A-level specification. A lab experiment is where the researcher is manipulating an IV and then they simply measure the effect on the DV. In this type of experiment, in a lab experiment, the experimenter has a high degree of control over the independent variable. They have controlled participants' allocation to conditions. Now, in a typical lab experiment, we might use an independent groups design. And this is to do with experimental design. And this is where we have some participants who are in the experimental condition and they are exposed to the IV. And then we have a control condition where there is no exposure to the independent variable. And then we measure these 2 conditions on the DV, and we see if there is any change between the experimental conditions performance on the DV and the control conditions performance on the DV, and that allows us to make these causal claims about the effect of the IV on the DV. So, for example, we might be looking at the effect of caffeine on alertness. Caffeine being our IV and alertness being our DV. And then we might have 2 conditions. One condition that drinks a cup of coffee and one condition that doesn't. And then we measure their reaction time. And so we're able to say the effect that caffeine has on alertness. That would be a typical way that a researcher here has manipulated the IV by allocating participants to conditions, where one condition consumes coffee and one doesn't. And that's how they've controlled the independent variable, by assigning participants to those 2 conditions. Or we could be looking at a repeated measures design, and this is where all participants are in both conditions. So on day 1, they will all drink coffee, and that's going to be exposure to the IV. And then on day 2, everybody comes back, and there's no coffee, and that's our control condition. And that's why I've put and or here. The researcher has allocated participants to conditions. They have allocated them to either the control and the experimental, in the case of an independent groups design, or they have allocated them to both the control and the experimental, if it's a repeated measures design. For now, we're not going to get too hung up on that. All we need to know for a lab experiment here is that there is a high degree of control over the independent variable because the researcher has manipulated their conditions by allocating participants to those conditions. A lab experiment also takes place in a highly controlled environment. And this is usually a lab, yes, hence the name, but it doesn't have to be. What we mean by a controlled environment could be a classroom where everything has been standardized. It could be a boardroom where meetings are taking place and we're able to precisely standardize the number of chairs in the room and the lighting and all of those sorts of things. All it means is that there's a high degree of control, which means that we're minimizing the possible impact of any situational variables. By standardizing, we're able to easily replicate. So we're talking about a really reliable, really internally valid procedure when we're looking at a lab experiment, typically. Now we move on to look at a field experiment. This is another true experiment. The lab experiment is a true experiment and a field experiment is a true experiment. And this is where, again, the researcher manipulates the IV in the same way that they would have in a lab experiment, where they might have participants in one or of two or three conditions. So for example, Bickman's study was a field experiment where there were three conditions that participants were allocated to. They had the security guard, they had the milkman, and they had the plainclothed pedestrian. So participants were allocated to one of those three conditions, and that was under the control of the experimenter. So in a field experiment, the researcher still has a high degree of control over the IV. They're still manipulating the conditions of the IV. But the way this differs from a lab experiment is that rather than taking place in a controlled environment, this is taking place in an everyday environment. I'm using the word everyday here rather than natural very, very consciously. I'm using this term every day. So what we're talking about here is in the field, hence why it's called a field experiment. Not in a lab, but in the field. In the case of a field experiment, we don't have the same control over situational variables and the ability to standardize as we would in a lab experiment. If we think about Bickman's study again, this took place on the streets of New York, where anything could happen. Even little things like the distance between the security guard and the pedestrian might have been slightly different than the distance between the milkman and the participant. And so all of these little things mean that actually there's lower internal validity. There are more situational variables that may have impacted on the IV, which means that now we're a little bit less confident perhaps about the effect of the IV on the DV, because these situational variables may be impacting. But the advantage of a field experiment is that because it's happening in the field, because it's happening in a more everyday or a real life setting, we might be able to make claims about the greater ecological validity of our research. For example, comparing Bickman's research on obedience to Milgram's, which took place in a lab, clearly there are going to be issues of artificiality in Milgram's research that don't apply to Bickman. Okay, now we move on to look at our two types of experiments that are not strictly true. These are not true experiments. And the reason for that is simple. The reason that a natural experiment is not true is that the researcher has not manipulated the IV. Unlike in a lab experiment or a field experiment where the researcher has had a degree of control over the conditions of the IV, in a natural experiment, the IV has occurred regardless of the researcher's influence. In a natural experiment, the IV is determined by some sort of naturally occurring event beyond the control of the researcher. This event occurs anyway. It occurs naturally, hence a natural experiment. And the researcher then just simply measures the effect of this event that already occurred naturally. So some examples here. We see lots of examples of natural experiments in economics, for example, where we might see, we might measure some sort of impact, like it could be GDP, growth of the economy, before and after a particular government came into power. It could be, I've got some other examples here, looking at levels of depression in adolescents before and after COVID-19. Right, in that example, the researcher wasn't responsible for bringing about COVID-19. that event was naturally occurring and it would have occurred regardless of the researcher measuring the DV, measuring mental health. So in all of these examples, we see that there's some, there are conditions that exist before and after the introduction of television, or hand-washing behaviour before and after a pandemic, or being raised in a loving home versus suffering from maternal deprivation or neglect. In each of these cases, we have a control and an experimental condition, or we have two different conditions, but the researcher has not manipulated those conditions. The IV has come about because of some naturally occurring event beyond the researcher's control. When it comes to the location or how, under which conditions the IV has been manipulated, for a natural experiment, that's not so important. A natural experiment could take place in a controlled environment or an everyday setting. It really doesn't matter. So for example, we could be measuring hand-washing behaviour, which would be in the field, for example. We could look at hand-washing behaviour of doctors before and after the COVID-19 pandemic. So in that case, the researcher hasn't manipulated the IV, which would be COVID, and is measuring them in an everyday environment in the hospital. So here we've got features of a field experiment. Or we could measure IQ of children who have been raised in daycare versus those who have been raised at home. And so we're going to be measuring IQ in a really controlled lab environment using a computer, for example. So here we've got features of a lab experiment, in that it's taking place in a controlled environment, but the DV of IQ is being measured in a really controlled way, but the IV of whether they were raised in daycare or at home hasn't been manipulated by the researcher. They didn't decide who was going to be raised at home or go to daycare. That was decided by the parents. And so, therefore, this was an event beyond the researcher's control. So, just a little point of comparison here, because it's really easy and students quite often get mixed up between a field and a natural experiment. The key difference between these two types of experiments is that the IV is manipulated by the researcher in a field experiment, and the IV is not manipulated by the researcher in a natural experiment. So in a field experiment like Bickman's, the researcher is allocating participants to their conditions, typically through a process of random allocation. But in a natural experiment, for example, looking at the impact of hand washing before and after COVID, that IV before and after COVID hasn't been manipulated by the researcher. That event is pre-existing, that event is naturally occurring, and the researcher simply comes along and measures the DV, hand washing. In a field experiment, it takes place in an everyday environment, like on the street or in the classroom or in a hospital. But in a natural experiment, well, it could take place in a controlled setting or an everyday environment. It doesn't really matter. What matters is how the IV was manipulated. Because the IV was manipulated by the researcher in a field experiment, this is classed as a true experiment, but a natural experiment is not classed as a true experiment because the researcher has very little control over that IV. Moving on to our last type of experiment now, we're now moving on to look at a quasi or a quasi experiment. In a quasi-experiment, the researcher has not manipulated the independent variable. This is similar to a natural experiment. However, in a quasi-experiment, the IV emerges because of the pre-existing individual differences between people. So in this case, we have conditions. We have condition A or condition B, or we could think of these as a control and an experimental condition, but doesn't have to be. It could just be two conditions. And in this case, the IV, the difference between those conditions, comes about because of who is in each condition. They have some pre-existing individual difference, which means participants can only be in one condition or the other. And those conditions, therefore, are predetermined. Therefore, the IV is predetermined. So some examples could be age. We could have people who are younger than 15 years or over 15 years of age. Now, those conditions already exist. You can't allocate people to those conditions because their age determines their condition already. So this is a pre-existing individual difference. So our IV is age, but that's not been manipulated by the researcher who has no control over the age of people. Their age exists already. Some other examples could be whether people have a phobia or no phobia. That's an individual difference that the researcher can't manipulate. They can simply measure the effect of, for example, anxiety of these two conditions, but the researcher can't manipulate these conditions. The conditions already exist as a result of the individual differences between people. So we've got a range of different examples here. Basically, we are just talking about individual differences between participants. That will determine the condition, and that will determine the IV. Like a natural experiment, this can take place either in a controlled environment or an everyday environment. So it could share features with either a lab or a field experiment, depending on where we're going to be measuring the DV. So I think what's useful is this tree diagram. I think this is the most useful way to look at the differences between true and not so true experiments. So these are our true experiments. And the others are not true. So the first question you need to ask yourself, was the IV manipulated by the researcher, either allocating participants to one of two conditions or by allocating participants to all conditions? But the researcher has control over the IV. If the answer is yes, then we know it's a true experiment. So now what you need to ask yourself is where it was conducted. Was it in a controlled environment? If so, it's a laboratory experiment. If it wasn't, if it was conducted in an everyday environment, then we're looking at a field experiment. So going back to the top, was the IV manipulated by the researcher? If the answer is no, in that the IV was naturally occurring due to either an external event or individual differences between people, if the IV already exists and the researcher is simply measuring the DV, then we're looking at an experiment that is not classed as true. So now the question we need to ask ourselves is, was the IV due to the individual differences between participants? Are we looking at some innate feature that determines who is in condition A and who is in condition B? If we're looking at some sort of innate individual differences, then we're looking at a quasi or a quasi experiment. If not, if we're looking at a naturally occurring sort of external event, then we're looking at a natural experiment. So this is a flowchart to go back to all the time. You need to ask yourself this question first and foremost. Was the IV manipulated by the researcher? If yes, then we're looking at a true experiment. If no, then we're looking at a natural or a quasi. Then you can further ask yourselves these questions to determine which one within those two. So at this point, I would like you to complete this table. This is going to be really, really helpful for you to look at sort of strengths and weaknesses of each of these different types of experiments. And we'll do plenty of application together in class.